Okay. Uh, yes. So now I think everything is fine and my screen is visible as well. My voice is clear to all of you. So the method which we are going to discuss today is a shooting method. Okay. And I would like to share little information about the shooting method. Then we will discuss everything one by one. So the basically the method we use for boundary value problems, and before starting or to implement this method, we need to convert the given boundary value problem into initial value problem. So in this method, the given boundary value problem is the first transformed to the initial value problem. Okay, and then the problem is solved by Taylor series method or Rangata method, etc. We can use. Okay, and finally, the given boundary value problem can be solved. Suppose that we are given y double dash is equal to yx, and this is ya. Okay, so we are given these 2 points. At this place, we have a and b. When x is equal to a, we have the left boundary value, and this is the right boundary value. Okay, and what we need, we have to assume y dash a is equal to m, which represents the slope at the point a to the curve. Okay, and we start with the two initial guesses for m. Okay, we will choose two initial guesses, say m naught and m1, and we need to choose all these two values, and then after with the corresponding values to the yb. Okay, and these are say ym naught b and ym1b, and assume that the value m and yb are linearly related. Okay, so this is the basically given the relation. Okay, but when we will implement the same, we need what will happen there. Come to this point, see in this diagram. So here you can easily see this is the point B, this is the point A. This value is given to us, which is YA, and at this place, this is the exact value, okay, YB. So this is the our desired value. So initially, we will choose two values of M. Here is M naught and M1. So at this place, we have the slope is in this direction or in this direction. So when we have this solution corresponding to this value, okay, y dash a, and this is the corresponding to y dash a, when we have slope is m1 and m2. So corresponding to this, we will find out the solution, and that will be this will shoot at this point and this point corresponding to these two values. And by applying the iteration, we need to get this value. Okay, so these will be the approximate solutions. And after that, by using curve fitting, okay, so this will be the required value which we need to shoot to get the exact value, but we need interpolation. Okay, with the help of interpolation, we can get this value. So we will start with one example. Okay, this will help you, and how we can convert the given boundary value problem of a second order. We need to convert the same with initial condition, initial value problem. Then we write the program and we will implement to find out the solution. Okay, and later on we will try to compare the solution also. But first, the most important thing is how we can shoot the value to get the solution of the given boundary value problem by using this method. Okay. So here I want to close this page and yeah, just 1 minute. Okay. Yes. So here we have is we want to solve the boundary value problem. We want to solve this boundary value problem. And the boundary value problem we have is x square y double dash minus 5x y dash then plus 8y is equal to 2 log x. And y1 is equal to 0, y2 is equal to 1. Okay, so when we have x is equal to 1, y is 0, and when we have x is equal to 2, y is equal to 1. So the interval we have is 1 to 2. This is the x span. Okay, so we want to find out the solution of this boundary value problem by using shooting method. Okay, we are using here shooting method to find out the solution. Okay, so what we do, and when we are going to apply shooting method, we will take the step size uh, h is equal to 1 by 4. Okay, the step size here which we will choose is h equal to 1 by 4. So the first thing is we need to convert this given boundary value problem into the initial value problem. So this is the very first step, boundary value problem into initial value problem. How we can do? This is very quite simple, and along with when we are going to convert this equation of the conditions which we are given, y1 is equal to 0 and y2 is equal to 1, and the thing is which we need to convert this boundary condition into the initial condition, and you see that this equation is in second order. So we need y dash 1 is equal to alpha. Suppose that alpha is slope 8, x is equal to a. Okay, x is equal to 1. So this is the slope. And the corresponding value on the right hand side we have is y2 is equal to 1 and y1 is equal to 0. So this alpha is unknown. This alpha is unknown. So we need to find out the value of alpha to get the exact solution when we have x is equal to 2, y is equal to 1. Okay, so we will start by assuming two values of this alpha. Okay, so we have now these two equations. One is the two conditions. One is y1 is equal to 0, and the other condition we have is y dash 1 is equal to alpha. Okay, from these two conditions, we will convert this equation into initial value problem. Okay, now these two equations are system of equation which are initial conditions. These are the initial conditions. Okay, and we need to, our task is, what is our task? Our task is find the value of alpha. This is our task. Task is find the value of alpha such that y2 is equal to 1. Okay, this is our problem, and these are the initial conditions, and this is our task. We need to find out the value of alpha at which y2 is equal to 1. Okay, so for that, what we do, we will take, here is x naught and here is uh, x naught is equal to 1. Okay, and we are taking h is equal to 1 by 4. Sorry, this is 1 by 4. The step size is h is equal to 1 by 4. Okay, so at this place we have x naught is equal to 1, then we have x1 and x2 and x3, and this will be x4. X4 will be equal to 2 and x3 will be equal to 1.75, x2 will be equal to 1.5, and x1 will be equal to 1.25. Okay, so at this point we have y naught, which is 0. Okay, this value. Okay, and when we have x2 is equal to, this is y4. This is y4, which is equal to 1. And these values are unknown: y1, y2, and y3. These three values are unknown. Okay, so hence use these values and value of alpha to find. We will use the corresponding to these values to get the value of alpha to find out y1, find y1, y2, and y3 using alpha. Okay, so now this is the stage where which we can easily convert the given boundary value problem into initial value problem. For that, let z is equal to y dash. Z is equal to y dash. Okay, and z dash will be equal to, sorry, this is z single dash. Z dash will be equal to y double dash, and we can get the value of y double dash from the given equation. From this place you can write the value of y double dash, and y double dash will be equal to 2 log x, 2 log x. Okay, and then we have a plus 5 xy dash and plus 8y. Okay, so sorry, this is minus 8y. This is minus 8y, and upon we have x square, and upon we have x square. But y dash we have is equal to z. So you will use this value, replace y dash. You will have 2 log x plus 5x z and minus 8y upon x square. Okay, so now we have two equations. One is z is equal, y dash is equal to z. One is y dash is equal to z. Okay, and second we have is z dash is equal to 2 log x, 2 log x, and plus we have is 5xz minus 8y upon x square. Okay, someone raise hand. Just 1 minute. Okay, okay, okay. Uh, yes, please. Someone
Yes,
raise.
sir.
Yeah, please.
Yeah, I'm saying that in the assumption part, you assume it that z equal y dash.
Yes.
Yeah. Instead of that, you can assume that z equal y first, because the entire equation it will go to change to be in the variable single variable z only.
When
Now you
you
have
will
the
put
two dependent variables z and y in the same equation. I think better to let it one dependent variable.
it's our choice. Okay, it's our choice how you want to replace the equation. But if we choose the another variable, this will remove the confusion. First, see here once again. Okay, there is no difference. Yes. Uh, okay. So when you will take z is equal to y dash. Okay. So you can easily use in this equation to get the value of y double dash, and in the place of y you can do. Okay, so this equation we need to reduce this equation into initial value from, and corresponding to these two equations we also required their initial conditions. Okay, if you will choose y dash is equal to z or y dash is equal to other variable, this will help you to convert this single equation into the system of equation. Ultimately, we will have two system of equations. Okay, so when you will use this one, and you will get the value of z dash, z prime will be equal to y double dash. Okay, and this value you can get from the very first equation. Okay, and y dash again can be replaced into z. So you have now these two equations. This is now system of equations. Okay, one is y dash and other is z dash. Okay, then we need the conditions also. So you can see that for the first equation, y1 is equal to 0 and z1 is equal to alpha. Okay, z means what is z? Z is equal to y dash. Okay, so y dash 1 is equal to alpha. That's why we have z1 is equal to alpha. So far, now these are two equations and both are first order, and along with we have the initial conditions. Now we need to solve this equation. This is system of equations. Okay, and for that we have ODE 45. ODE 45 is inbuilt function in the MATLAB, which we can easily use to find out the solutions of a system of equations with the initial conditions. Okay, when we have system of equations or system of differential equations in the first order, okay, you can easily use ODE 45. ODE 45. Okay, this is the inbuilt function in the MATLAB. So with the help of this inbuilt function, we can easily find out the solution of this system of equations. Okay, and along with we have to to implement this one. What we are doing, we will write the both the equations like in this way. Y vector is equal to y is uppercase, and here is we have y and z. Okay, the y1 is this is y1 and this is y2. Y1 is equal to we have is y, and y2 we have is equal to z. Okay, but you can see y dash. You can see, just 1 minute. Yeah, you can see uh, again. I am repeating the same step. Y is equal to we have is y and z, and implies y1 is equal to y and y2 is equal to z. And also, y dash z is y dash is equal to z. The meaning is that z dy upon dx, dy upon dx will be equal to fxy, f comma xy. And in the initially, we have to assume the value of alpha, and we need to choose two values. So here we will let alpha 1 is equal to 1 by 2, and alpha 2 is equal to minus 1 by 2. Okay, so these are the two slopes. We can choose at the 45 or minus 45. Okay, so initially these are the values corresponding to this one alpha. Okay, and when we are going to implement the shooting method, for that this is the target value or the exact solution which we are given is at this place y2 is equal to 1. Okay, one is here is alpha is equal to 1 by 2, alpha 1 is equal to alpha by 2, and other is alpha 2 is equal to minus 1 by 2. Okay, so initially we will start from these two values, and these are the two slopes. Okay, y dash we have a slope at the point 1. So we will choose these two values alpha 1 and alpha 2. So now we will start with the MATLAB also, and then step by step we will discuss everything. I have to close and now come here MATLAB, and the script file I have prepared completely. Yes, come here. So what we are doing here, these are the initial values. You can see x naught is equal to 1 and xn is equal to 2. Okay. So in our problem, we are given the interval is 1 to 2. So x naught is equal to 1, and this is the last value which is xn. Okay, xn is equal to 2. H is equal to, we are choosing at this place 1 by 4, and corresponding to this value which is y naught. Okay, when we have x naught is equal to 1 and y naught is equal to 0, and when we have xn is equal to 2, then yn is equal to we have is 1. These are the given values. Okay, so given values we put at this place. Now we compute the function. We have system of equations. Okay, so here we have is y2 and y1. Okay, so this is the value. These are the equations which we simplify initially. So here one is y2 and other is y1, which is equal to 2 log x plus 5x y2, and y2 means z. Y2 means z. Okay, and minus 8y1 upon x square. And also for the initial guesses, we choose alpha is equal to 1 by 2 and minus 1 by 2. These are the initial guesses which we choose here. Alpha is equal to 1 by 2 and minus 1 by 2, which we choose. Okay, these are the two slopes. And for I is equal to 1 to length alpha, we need to pass this value and this value. Okay, so z naught will choose alpha I 1. This will choose alpha corresponding to 1 by 2, and then it will choose minus 1 by 2. Okay, and z is y dash. So this is the initialization of y dash. Okay, and x span. X span we have is this interval which is 1 to 2, 1 to 2. So this is x naught and this is xn, and we are choosing here step size is h. Okay, this is the step size which we choose at the place h. Okay, so this is the x span. Now the initial conditions. The initial conditions we have is y naught and z naught for both the system of equations. We have two equations. Okay, system of equations. which are one is y1 is equal to y and other is y2 is equal to z. Okay, and corresponding to these two equations, we have the initial conditions. One is y naught, y naught is y1. Okay, and other is z naught, which is z1. Okay, so these are the initial conditions, and these initial conditions are stored at this place. You can see y naught and z naught. Okay, so these are the values which we have corresponding to these initial value problems. Okay, now scroll down, and here we are using at this place ODE 45. This ODE 45 is inbuilt function in the MATLAB, and which is used for ordering differential equations. Okay, and we can use for boundary value problems. So there are several type of inbuilt functions in the MATLAB which we can use directly to find out the solutions of differential equations, a system of equations. Okay, and we can use this inbuilt function for partial differential equations also. Okay, so there are many inbuilt functions in the MATLAB, and we can check ODE 45. Yes, you can see there are several methods like ODE 145, which is highly used for non-stiff differential equations. Okay, and when you will click on it, yes, you can find the corresponding syntax how you can use. So Ty is equal to ODE 45, and here we have the ODE function. Then we have T span, and this is the y naught, which is initial value. Okay. Similarly, when you have if other conditions are given, then you can use this one. And also, when you have Ty and Tey, you have system of equations. Okay, then you can use this one also, depend upon the problem. Okay, and corresponding to this, you can find here some example also. Yes, so here is the example to use this ODE 45. Okay, here you can see this is we have y dash is equal to 2t, and this is the interval, this is the initial value, and t span is equal to 0 to 5. You have to store in the MATLAB, and this is the initial value. Okay, and then you can easily apply this ODE 45 to find out the solution corresponding to this equation. Okay, so you can easily use this method for different type of problems, which is inbuilt function, and here we are using to plot the graph of the above problem by using ODE 45, which is inbuilt function in the MATLAB. Okay, so here is one more example. Several examples are there you can use for different type of problems. And here you can see this is the boundary value problem, I think. Yes, here you have this equation and two conditions are given. So you can reduce this equation into the first order. You can see. Okay, so in this way you can easily convert the given uh, second order or third order differential equation into the initial value problem, and then you can use this method to find out the solutions of different type of initial value problems. Okay, so the same approach we are using in our method to find out the solutions of the initial a system of differential equations. Okay, initial value problem. Okay, so here when you will here just 1 minute, I want to comment these equations. First, I am commenting this equation. Control R. Okay. and shoot I. When we will execute these equations and this system of equations, see what happen. Okay, plot is there also. Okay, some statements we have height, control R, and yes, and remove. Okay, so these are the values. These are the values corresponding to two. One is just 1 minute. End value y, comment this one. Okay, and cut from this value and use here. Yes. So this is the last value. This is the last value, and when you will take at its place 2. So this is the value corresponding to y2, and this is the value corresponding to y1. Okay, but these are not the exact value according to our requirement. Okay, these are the approximate value corresponding to the slope when we have alpha is equal to 1 by 2 and minus 1 by 2. Okay, so now what we do, you can check all the values, and if you want to check the values for all vectors, for all rows but first column. So these are the values for all corresponding to this is the first x naught, x1, x2, x3, and x4. Okay, x naught, x1, x2, x3, and so on. Okay. So if you will take at place 2, this is the value corresponding to y2. These are the value corresponding to y2. Okay. So now these are the values which are computed corresponding to by using the initial value problem, but the value of alpha is 1 by 2 and minus 1 by 2. Now the thing is we need the exact solution, and we need to implement interpolation. Okay, and how we can use? You need to uncomment this one and here semicolon. Now, yes. So here we are using interpolate to shoot our value. Okay, so here is alpha is equal to interpolate, and the value which we are shooting now, shoot I, and the all the values which we are getting at this place, shoot, and alpha. Okay, the value which we choose corresponding to alpha, this is the yn is the last value. Okay, so by using this interpolation, we want to target this yn, and using linear and linear extrapolation. But here for the initial condition, y naught, we have now alpha. Okay, because corresponding to alpha, which will be updated at this place, which will be computed and the above, and iteration will be used until we have the exact solution, or the this value will be shooted. Okay, so here IC will be taken as y naught to alpha. Then we have xy is equal to ODE 45. Again, we are using by using the this value, okay, but the solution will be updated from this ODE 45. The equation we have is the same, which is ODE stored in function f. Okay, and here is x span. Either you can store these values, the value for initial condition, y naught and alpha. Okay, we are using this value for interpolation. Note this point very carefully. We are using this value for the interpolation to make shoot the value. Okay, this will make our solution accurate. Okay, then after by using the same ODE 45, F is there, X span, and at this place you can use IC. You can use IC. Okay, because IC is stored at this place. Now, this is the output value. Okay, and this will return us the solution of Y, and this is the display Y. Now, when you will run, okay, you can see this is the last value. This is the last value, and this is the first value of Y, and these are the intermediate values. This is Y naught, this is Y4, this is Y1, this is Y2, this is Y3. Okay, initially these values, when we simplify at this place, these were not accurate according to the value of Y4 was not accurate. Okay, so by using the interpolate, and also the loop is there which will initialize and will repeat for at this place also, but we need to interpolate by using linear extrapolation, and with the help of this linear extrapolation we can shoot the required value, and you can see at this place uh, the boundary values are here which I highlight, and these are the intermediate values which we can get in this way. So this is the all about this method, how we can implement. Now, any doubt in this method which you want to know? Yes, please. Any question, please? In the beginning, this will be hard to implement. You need some more examples, okay? And some more concept about the linear interpolation. This also be used at this place. So we need to interpolate the value, and you can use in this way. The main purpose is to find out the value of alpha which will get this value yn. Okay, we have two values. See again, what is our purpose here? Just to find out the value of alpha. Okay, this was the our problem in this way. This was given. Okay, so this is the alpha 1 which is 1 by 2, and this was the solution corresponding to when we have alpha 2 is equal to minus 1 by 2, and we need this value alpha. Okay, so we need to find out the value of alpha which will shoot the value at this place, which is 1, y is equal to 1 when we have x is equal to 2. Okay, so you will initialize from these two values, and this will be fitted with the help of interpolate. So interpolation is also required to use at this place, and you can easily use interpolation in this way, and you can find here the value of y is now exact at this place. Okay, so this is the initial value y naught, this is the y1, and these are the intermediate values. Okay, so if you want to change the step size, you can do here. You can take at spaces, you can change the step size. Suppose it is 8. Okay, and run the file. You can see our shifting method is absolutely correct. You can make more small step size, and you can use this approach for all type of methods, all type of differential equations. Okay, we can take here is 20 and see. So the initial value we have is 0, and this is the boundary value when we have x is equal to 2, and all these are the intermediate values y1, y2, y3, y4, and so on. Okay, so this is the approach to write the shooting method and how you can implement. but you need to get some more detail about the shooting method. Okay, if you can solve this one example or two example from this book which I have already provided you, this will make more helpful to use this code. Okay. Now, please let me know if there is any question, any doubt regarding this shooting method. Any question, please? Any doubt, please? Dr. Dinesh Moroz, Maridula Jain, please let me know if there is any question, any doubt. Dilip Kumar ji, Dinesh, I am not getting your voice is breaking.
Thank you, sir. Everything is fine, sir. Very fine.
Very clear. Uh, uh, I will provide some more code because one example is not sufficient. And due to lack of time today, I was not able to write the PDF file complete procedure. I will, after completing the complete procedure, I will upload the PDF file, and also I will try to share this PDF file in the WhatsApp group. Okay, and the script file will be available without this script file. But what you will do, you will do some more examples using this code. Okay, you will choose your own example, you will choose your own example, and what you need to change only, just you need to change the initial value and this function only. Okay, rest the other part will same, only your problem will change. Okay, and how you can convert your problem into a boundary problem into initial value problem, and then just you need to change only this part. Okay, and one part is missing in this example, that is the comparison. Okay, I tried to write the comparison in the same file, but there was small error. After checking the same, I think while writing, I make some error. There is some error. Okay, that's why the comparison is not according our desire. After correcting this code, then I will provide you. So this is the complete procedure about the shooting method, and I hope that this will help you. And there are some other methods also for which are inbuilt in the MATLAB. Okay, once again you can see here there are many inbuilt functions. Okay, just like you can see OD45, then we have ODE23. Okay, this is also inbuilt function which we can use. But there are some specific reason to use all these. ODE 15 is also there. ODE 15 15 is also there. Yes. ODE 15. Okay, I think it has been changed. Yes, now these are 15s. In the older version of the MATLAB, these were ODE 15. Okay, but now these are changed into 15s. ODE 23s, ODE 23T. Okay, there are several inbuilt functions which we can use. Here you can see the maximum orders of this type of inbuilt functions, and all these are known as solvers for differential equations, and all these solvers are available for ODE as well as for PDE. But before using, you need to clear which solver is useful for some specific problem, and all these solvers which are available in the MATLAB have some specific conditions where we can use. Okay, for this there will be some special session about these solvers, which are also helpful to solve the different type of boundary value problems as well as initial value problems. If you have no question, now we can close the session. Tomorrow there will be two sessions. I want to organize two sessions tomorrow. Okay, and the schedule for the same I will share with you. And Sunday there will be session in the morning, because in the evening I will not be available. So all the content I will try to upload as soon as possible. And for the tomorrow, there will be only half hour gap between the two sessions. Okay, and be available according to the sessions. So if you don't have any question, then we can end today's session. Thank you.
Thank you, sir. Thank you. Good night.
Thank you. Thank you all. Good night. And
Thank you.
tomorrow we'll join 7 p.m. Okay. Thank you to
Thank you,
all.
bros. Thank you.
Okay.
Thank you.